Hello, everybody, and welcome to another episode of BLS031 Show and Tell. And with me, I got Thomas BURLESON. Thomas, how are you doing?
I'm doing really well today. Thanks for having me on the show again, B.
Thanks. It was a great success last episode. I think we really had some external meetings that limited our time on the show. So it's good to have a version 2. Hopefully, I guess I pinky promised on Twitter yesterday night that we will do any React Akita today. Hopefully we will. For those of you that didn't check the last episode, go ahead in my history. I'll make sure to link it below as well and check it out because it's an interesting episode where we discussed basically reactive state in React using its native operators, mainly use state. Now, between last week, I actually went ahead and go berserk on my app, and it's a complete different app. It's actually working right now. It's implemented, and I went ahead and bring over all my prototype code into this. And I think what I ended up with is a pretty common React app with a few common concerns that I have. So the goal today is to go over these concerns, look at the app, and then let Thomas suggest what is a nice solution for these kind of things or part of the issues, because the apps become pretty vast and it's a different beast than last week.
Now, B, you mentioned just a minute ago something about React Akita, and I wanted to suggest that when I originally started talking about this architecture feature, this solution that's now available, I said it was based on React and based on Akita. However, I've been mentally thinking of it now as reactive stores. Regardless of how it's implemented on the hood, I think of it as reactive stores. And that fits really well into what you just mentioned a minute ago, where you were saying that last week we used React hooks, just the raw traditional hooks, to manage some local state. And our UI would react to changes to the data in that local state, right? And however, that term UI reacting to the change in the state is a little bit overloaded in my opinion, because what it doesn't do is if you, within your raw traditional hook, like use state, you say set state to a new value, then the UI component associated with that hook will re-render. It will trigger a re-render. But what it doesn't do is it doesn't allow you to easily share state between components. And it doesn't, and React, the reactive stores does. And the other thing it doesn't do is if you're actually just watching a blob of data, then how can you observe that data? So if any parts of the data changes, anyone can get notified. Right? So in other words, it's almost as if it's a stream that just notifies you upon changes. And again, reactive stores do that. And that's really the thing that I want to try to promote more in the community. And we're going to be using here with your stuff, because the code you've written presents some really interesting ideas and approaches. However, one of the things it doesn't do is it still falls into this, what I call pull-based approach, which is you're asking for the data gets delivered and you render it, right? And then if you deliberately make a change to that data, then the UI will re-render. But what we want is that if any changes happen for the source of the data of store that we're interested in, those change notifications percolate out from the data, not from the UI. So right now with providers, the change notifications percolate down the view tree. What we want is the change notifications to come from the data sources.
Right. Yeah, that's a great thing. I think let's pull up the app. I think that's the easiest, so we can take a quick look at how it's implemented and what it's actually doing. So let me put ourselves on the front row here. So what we have here is a web wallet for a cryptocurrency. So you can see that you can have various wallets. And if all goes well, I should be able to send one KIN, which is the currency we're using, to another address in my wallet. And it's all still pretty much in progress, so it could as well fail, but looks like transaction submitted. And then after a refresh, bam, you see that the top level wallet now has 1 kin and the other has 999. So basic functionality, this stuff gets persisted in the blockchain. It's going to be there forever, ever. And we can even check it out if we would please so. But this is basically the real stuff. And I can see I received 1 kin and I can obviously send it back. So from a functional point of view, this app works. And I'm pretty happy with it, how it got together. And our discussion last week definitely helped me in making some wise decisions. But I couldn't resist copying over some of the technical debt I have. And I would love to show it. There's one feature I'd like to show you all. So you can instantiate a certain wallet in various ways, or an account. I'm kind of using these terms interchangeably. When I say wallet, you can read account and vice versa. It's not really important, the difference. But I can create a new account. This will generate my new private key, store it in my browser. So I get a hold of this. So all my transactions will need my key. There's no entity that's a custodian of my wallet. It's a non-custodian wallet. I'm the owner. That's one way. The other way is if I already have a existing key, I can import it. So I can put my secret in here, import it, and it will create the account for me. And I can do transactions on behalf. And the third one is actually just a watch mode, because all these wallets live on the blockchain. We can take whatever wallet address and just check what the balance is and see any changes there. So these are kind of the three main features. And this data gets persisted, as said, in your browser. I'm using a database called RxDB. And what it does is it stores this. It's basically an ORM, object relational mapper, on top of IndexedDB, which gives you all the nice qualities of IndexedDB, which is like high performance and widely supported. It's fast. And it gives us a very nice UI, a very nice wrapper. And I got a small database class, so we can do things like find me all the wallets, or find one wallet, delete, update. So that's from the data persistent perspective. And there's one thing that I think is interesting from a functionality, and this is here the network switch. So right now I'm connected to mainnet, which is the production level API of the kin cryptocurrency blockchain. And when I change this to testnet, you'll see that it will re-render my components, and it will see, hey, I don't even have an account on this test network. So your accounts need to be created. Now, this is not working flawlessly, because if I don't have an account, how can I have like 1 kin? This is just stale data, which is definitely a problem, an issue we can address. But yeah, if you see here, triggering a network change basically needs to reinstantiate and reconsider anything, because I'm connecting to a different API. So anything I might have in local state is basically worthless and needs to be reconsidered. So the database is a very low-level operator, and the network switcher is basically the second-level operator. Yeah, so that's from a functionality point of view. I'm not sure, Thomas, if you have any questions about the app at this point from a functionality point of view.
Not just yet.
Yeah, okay, so this is your basic crypto wallet. You can do sending stuff. You can do receiving stuff, but that's only really showing your address, so you can pass it along and scan it in. So we're interested in listing our accounts, creating them on the blockchain, making a transaction. That's the three main operators.
What are you using what are you using the local database for?
I'm storing the wallets.
Okay.
And this is the reason why it's considered secure, is that the wallets are stored in your browser. So I don't have to own your private key, because in the blockchain it works. If you have the private key, you can make any transactions on behalf of that account or wallet, and you can take all the funds and send it to your own wallet. So we don't want this key to be exposed at any point on the internet. We need it one time to create the account, but after that, there's no interaction of this secret abroad. So all these operations, and for instance, signing a transaction, which is the cryptographically secure way to say I agree with this thing, that all happens in the browser. When I send a transaction just a minute ago, what I did was partially sign a transaction, send this to the API, and it will take it over and handle it and make sure it lands in the blockchain, and it eventually is persistent. So I think in a normal app, and then let's tune into the database directly. So I think with a more classical app, most data stores are going to be a remote API. That's at least what, like, maybe 99% of the apps I work with are remote APIs. This use case is a bit special because we have to deal with secrets, and we really want to just this app should live all offline. Although it doesn't make sense to have a cryptocurrency that's offline, but it should be all in your browser. There should be no server side. It should be hosted on like GitHub Pages or Netlify or Firebase or S3. And so I'm going to go ahead and check here. So here this is my endpoint where I say get DB, and this will create a database for me. Now, what we're looking at right here, this is a wrapper around RxDB. So this little package RxDB here delivers a great database, and it's pluggable. So it also works on Node if that's what you want. It can work in the browser. It can use on React Native. And what I did here was add a simple class that's my collection class, and I can pass in a generic here, and then I have a few operations. So I got nice typed responses, and I can just define them here. And then actually the database interface that I created has an instance, has a reference to the actual Rx database. And I got 2 of these wrapper methods here wired up. So my syntax will be something like db.wallet.find many if I want to get my data. And I think this is pretty nice expressive API, and I don't really care how it's implemented in the back. And if at some point I want to reuse this wallet code and do connect it to a remote API, in theory, I only have to re-implement the database. We know in practice it's probably a bit more work, but the theory should be fairly simple. Now, this also comes with a nice challenge directly, is that this create database, which is the thing we actually call here, create database, pass in the adapter and the name. This is basically my abstraction, and this is what I would need to re-implement if I run it on React Native, for instance, because we don't have IndexedDB there. But all the rest should be agnostic for implementation. But what happens here is that it's already using async await to create the database, to create the collections. I need to set up my collections, and this happens on each refresh because we're in a browser. We start from 0. So each time we have a refresh and RxDB starts, it tries to create the database. It finds our existing data in IndexedDB, and it populates our database, so to speak. But this already, for me, comes with a few challenges because this is promise-based, and I actually don't want to have anything to happen before this database is initialized and before this thing is ready so I can actually ask data. But so that's the database part.
What do you mean by you don't want to have anything to happen? You mean that you would like a please wait screen while the database is initializing and preparing?
Yes, and to give you an idea why, I basically miss the momentum where I can say, okay, first make sure that this is all done. In this case, initialize the database and then move on. If I would map to Angular, I would consider, if it's really extreme, I would consider app initializer, and I would probably do it there and prepare all the stuff there. So I'm sure this is the first code that's get ran, and it returns a promise when it's done. And then I know after that, I have basically a guarantee that I have a working instance of the DB. The other alternative I would consider was probably by using a resolver maybe, or a guard, something that's connected to the route and that basically prevents any routing from happening before this condition is met. In this case, database is charged.
Mm-hmm. There's several ways you can do a guard in React, right? You could simulate a guard by just not rendering the component until the database says it's ready, or you could use an actual guard higher order class to do it. There's a whole bunch of ways.
Yeah, right. I think I would definitely, I'm definitely going to consider doing this because right now it's, I've used the Elvis operator a few times, basically to not throw an error if my database is not there, and I have a bunch of if statements in my use effects. So use effects watches the DB property, but as long as it's not there, it will basically fall through. All workarounds that I learned in my last few years working with React that make it workable, but it's definitely not something I really feel well about that I don't feel like I own the problem. I feel like I've found a way to work around it, but I'm definitely not in a position where I own it. Now let's quickly look at where this got initialized. So what I did was build a provider. We didn't talk about providers, I think, last week. We talked about them where we didn't really use them. But I've learned to use providers, and since I knew it, it's basically been my go-to way to do anything outside of a component in React. So if I have doubts, I generally start building a provider and work with this thing. And the thing I really missed and I didn't understand up until last week is that providers can call other providers, and this is where you can make really powerful stuff. I never realized it. So I always was just including providers in components, and that's it. But this is the database provider. So what I do here is try to initialize the database. And I have it expose a loading property, so I can, outside of it, I can check if the database thinks it's loaded. And then the rest of the app can consider it being loaded.
So what I'm seeing here is that you can start getting a sense of there's a mixing of concerns here, right?
Right.
One is that you want to use a database service, and the other one is you want some state associated with, in this case, whether the database service is ready or not, right?
Yep. Yep.
And then that state itself is going to be used to either block or guard against routing or show a loading, please wait indicator, etc. The other problem that's going on here, other than mixing of concerns, is that we're using this provider, and providers are a very reasonable React approach to looking up from the view hierarchy, looking up services and data that's been populated in the view in the sort of the view context.
Right.
However, providers are not a good mechanism that you would use to automatically create your services, right? So for those of us coming from Angular, where we set up providers, we're used to saying this. For example, can you go into the database itself, the database class?
So this one?
So you have an interface, and you call create database. Okay, so this is more of a functional, and then you're returning, scroll down here, and then, right, so you're returning a structure that has this DB promise, right, which has the settings and the wallets. Does it have any methods on it?
Not, but it could definitely have methods. For instance, one of the things this database allows encryption, which even needs to take you a step further back. Say, hey, I want the user to enter a password in order to open this database. That's another topic that's basically in a month's time, it's going to be relevant.
Well, that's related to your guards too, right? Because then if your guard puts in a login, the login is required before the database can be initialized, and then that login passes that to the database.
And totally correct. And then we're going to get it even more interesting, because where are we going to store the fact that we guard this thing? We're probably going to end up with another database, or I'm going to use local storage to set a flag. But so this is going to be an interesting thing. But in essence, this is the reason this is a function that I return is because this is how I ripped it from the README, and it works for me kind of thing. So I've been copying and pasting this along my apps. If I would do this myself, I would do a class-based approach. Instantiate a new class, make sure I got a reference, either pass you the reference to that class or instantiate a new one.
Right. So now if you go back out to your provider, so now that we've seen that you're using this, and by the way, when you call, I don't see it here, database
getDB.
Create context. Oh, here we go. You call getDB.
Yeah.
So this one just calls that function, create database, with the adapter and a fixed adapter name. Yeah. All right. But what we can think of, what comes back is not so much it's like a facade, isn't it? Because it has wallets and it has settings, and you have different methods for wallets. Wallets is like almost has an API. So it's not just data, it has API, right?
Correct. Yeah.
And settings probably has just not only the data, but probably an API for that. And so what your database is here is also, it's sort of mixing things a tiny bit, right? Because it, and we'll come back to that later, but really what we want is we want to create an instance of the database, and we want that to be globally, we want that to be available at the app level. So anyone can look it up, right?
Yeah.
So one of the reasons I like dependency injection is I like having explicit control over the creation process.
Right.
And with DI, I know exactly how to configure what things need to be created, what their dependencies are, and then I can even then override those dependencies to specify mocks and other things on the fly, right?
Yeah.
Or if I wanted to do a different database, I could inject a different database that would then be used. So what we're hinting at is injection, of course, is using it through either a construction function, or excuse me, a class-based constructor, or a factory function that takes some arguments in. But either way, injection happens in as arguments into some method or function call. So what I would be doing here is, I'm trying to think here, because you have, let's show everyone your provider tree that you've got in your app.
So one thing I quickly want to point out here, and this is where you can see I got a settings page. This is not publicly exposed. At some point, this will be fancy, and you can actually set stuff here. But for now, it just renders out whatever I have in my settings. And if I switch here to another different network, this gets persisted. No issues here. But if you refresh, and I hope it shows, you should see it go to mainnet first, because that's my default. Then the database gets loaded, and then it figures out, oh, I actually got settings for you. So here, you're not on mainnet, you're on testnet. And this is like, it's probably an ordinary race condition, but this is something that I would love to prevent. And I know, you can see it being empty a little bit. So this would be great to have addressed. So this data level is really the outermost thing, and my settings system depends on it and everything. And let me open this to make it more visible. Going into app here, and then app.tsx. And I got good news for everybody interested. This app will be open source within 3 or 4 weeks. So you can all check it out and look at it. Now, this is my main application, and I don't recall exactly how Chow called it, but it's the Haikuna, I'm not sure how to pronounce this guy, but yeah, Dragon provider tree. And
that's funny, because I commented on the tweet and I didn't realize it was your code, B. But I think I said that this was horrific nesting.
Yeah, the screenshot from Trow is not my code, but it definitely shows the same issue. I think this is one of the main critiques that I read about React. If you don't have a solution for this in a big app, this is what you end up with. And bear in mind, this is a small app. I've worked on an app with, I don't know, maybe 20 piles of functionality. This thing keeps adding up, and you can separate it out a bit with routes, but it's definitely an issue. The one thing I do appreciate with it, but it's kind of a sour, no, I'm not sure, it's kind of a meh, let's put it this way. What I like, you can see the dependencies here literally, because you can see database provider, the settings provider depends on the database provider. And my network provider depends on the settings provider, because in the end, before I connect to a network, I want to figure out which network I connect to, which is stored in the database. And then for the network, I also need the prices. So check out what's the dollar value of this kin at this moment. These might be swapped around, I'm not sure. And then the wallet provider basically needs all of the above in order to do its work.
Right. So one of the approaches I tend to like to do within React is the providers that I have in this sort of visual tree are really visual providers, right? So I might have a route guard provider that's set up for that. I might have a theme, as you have it here, a theme provider. Yeah. I might even have a snack bar provider, but everything that's not, that is more data or services, I want to avoid using providers.
In general.
because what I want to do is I want to use dependency injection, right?
Correct. Yeah.
And so what we're going to do is, what I think we should do is we should set up a dependency injection system.
Mm-hmm.
And then we'll just basically, we're going to do database first.
Yeah.
And then we'll show how once that's DI is working, then you can configure the settings to actually use the DI to look up the database.
Yeah.
Instead of having a provider here. And then you can just start whittling away at your providers.
Yeah.
And
So
then,
from there on, it's basically ducks all the way down. I'm just going to do the same trick over again. Make sure I make it injectable so I can inject it elsewhere, and I disconnect, in essence, what's a hierarchical relationship right now.
right. What you'll probably find out, though, is you probably have code that is dependent upon the providers when the values change that the UI re-renders, right? And if you remove the provider here and you're only using an injector, then the UI, the injector never changes. The injector is managing a cache of services and data models. And so while those data sources and services may modify, the injector doesn't. So that means your tree won't change, right? It won't re-render. Yeah. So that means your hooks need to do something slightly different to observe the data that may change. So right. This is where, as we remove the providers, we might have the UI temporarily break, but we'll come back and fix that, because what we really want is two things. We want dependency injection that lets us look up services and data and configure how they're built, like when they're built and how they are built. And then we want to identify a way to create managed state. Sometimes this state is local to a view. Sometimes it's global and it's shared. And we may need to reset it. But regardless, when this state changes, then we want the observers that are dependent upon that state to trigger re-renders.
Yeah, I think that greatly describes what we're looking for and the concerns. I think yesterday, Serkan, who's also here, welcome Serkan. Yesterday, he posted a tweet about differences in Angular and React, and I think the way I formulated was the things I miss most is DI and observables, because these are my go-to key elements that have always been there in my recent apps, and it's really something I miss because it's a nice mental map. Having observables for me is a luxury. It's not a popular opinion by everybody, but I think it's a luxury to do all these things. And so very cool. I want to. So inside the settings provider here is where we actually use database. So here we grab a hold of this. Mm-hmm. In here you can also see where I suggested, like I'm doing DB ? So that it at least will not crash. React crashes dramatically. Whole UI is gone if you have a unhandled unhandled exception. And then here, this is what I think is closest to basically dependency. It's not even objection, it's observing the dependency, and this will trigger this thing each time my settings are there. But it's really hacked together. Right. It works good enough for the demo. Definitely not something I feel happy about. And if somebody would tell me there's a race condition in your app, I totally believe them. I would not doubt them. I would doubt my code. And that's not a good point. So this is the classic. I promise there's one other one. I want to quickly go over the other problem that we have, which is a classical one in React, which is called prop drilling. Now I'm going to go down here, and eventually we'll get in the wallet list component, which is this component. And if you see, for instance, here inside, I'm going to switch to mainnet. So I'm having my UI be at least a bit reasonable. So this is the wallet list component. This is basically my feature, and all the way inside here, it's all going to be UI dump components, probably, mostly. But here you see a modal window. And if you would look at the hierarchy of all the components, I think we're 3 or 4 levels deeper than the wallet list. And in order for this to work, if I click this button here, now the signal needs to travel all up. And I really want to show this for the people that are not aware of this. So this is the wallet list component. I fetch my wallets here. And at some point down below here, I loop over my wallets with a simple map, and I return this wallet list item. And here you can already see that I'm doing awful things with consistency, but as I said, I was in hack mode. But I have a handle delete, a create account, and a handle transaction. 3 fairly random operations of a wallet. And yeah, sure, they make sense in the context. But this handle transaction in the wallet list item is defined here. So I define here, hey, this is what a wallet transaction looks like. And then at some point, because this is a component, this is making sure this is basically a list item. This handle transaction gets passed here. It even gets renamed send transaction. Now get into send details. I got a very similar method here. And then eventually in the dialog, I got the actual send transaction. So I got 1, 2, 3, 4 components where I define the existence of this handle transaction method. And I think this is a classic example of prop drilling. It also goes the other way around with the inputs, where you say, hey, wallet, give me this wallet. Wallet gets passed in somewhere. Wallet might not be passed in. Wallet gets passed in here. Of course it does. Gets passed into wallet item, and then it even gets passed in down into the dialog. So I pop in a variable 4 levels deep, do something with it, and pop it out 4 levels deep. This works. This is how it's done. This is how the tutorials write about it. It's not scalable. And I think it's a common concern. I'd love to address this. I'd love to understand what's the way. I think I understand that having DI or maybe even some hooks would help it. What mostly worries me is, like, what are the rules? What are the concerns? Can my UI component load in consume a provider directly, or is that a bad design? These are kind of the concerns that I have with regards to this issue.
Whenever I see dialogues, the first thing I ask teams is this the only dialogue that will be open at one time? And if it is, then you take one approach. If it's some applications, you could have multiple floating dialogues open, and each of them is independent of the other. And that's a separate UX consideration, but the architecture to support that is more complicated.
Right.
So if you have just one dialogue that can ever be open, is that the case here in your application?
That's definitely the design. I don't really like having multiple dialogues in front of each other. And we will only ever operate one wallet at a time. It doesn't make sense to spend from 2 wallets at the same time. So
fantastic.
we can fairly safely say there's going to be one modal window, one dialogue at one time.
Perfect. And I think that old approach of multiple dialogues came into being because the UI frameworks at the time didn't really support this idea of tabs and multiple views. So people took a dialogue and they totally bastardized it to have floating dialogues, which then became full, like almost mini apps, right?
Yeah.
And that's, in my mind, that's not the intent of a dialogue. It's a pop-up or it's an area of the screen that's intended for your to provide extra information or specific interaction, like transient, temporal interaction.
In this case, you would agree with the usage?
What's that?
In this case, you would agree with the usage? Having a modal window to provide info for the dialogue, send it along, and forget about the operation?
Well, I was going to say that if you're going to have only one wallet dialogue ever open at a time, then you can do something where you can actually have the dialogue just ask the some state, which is, please give me the current selected dialogue or the currently selected wallet.
Yeah.
So the dialogue itself looks up the wallet that it's supposed to be rendering, instead of having it passed in via props, right?
Yeah.
And that's the alternate approach, because then your dialogue is super clean. And then you could have any dialogue, and if you needed to, maybe you wanted to have a dialogue for services, well then, or a network, then you could say, okay, what's the currently selected network? What's the list of all available networks? Whatever, right? It depends on your need. So
makes a lot of sense.
I'd say let's go back and start working on the database injector.
Awesome. I'm ready. Here's
the first
open.
thing to do is install the Mindspace utils. So yarn add Mindspace. Yep, that one. And might as well say at latest. Let's see which version it installs for you here.
Let's do it anyway, as I'm Control-Cing already. Okay, Mindspace, IO React. Mindspace is the scope you're using. Is that the company you work for? Is it your company?
It's my company that I've had for a long time. And originally I was publishing some Angular utilities that I really liked using and I had created. And then when I switched over to React, I found that I was really enjoying creating some wrapper utilities. One of those was useObservable, which is very similar to the async pipe. And then the other one was some switch case utilities. And then finally, they created create store, the reactive store. So it's a fairly lightweight application or a set of library utilities. It's, in this case, React, mindspace.-io/React depends upon RxJS. It uses Akita, and it uses Immer, all under the hood, okay?
Yep. Okay, nice. It takes a little bit. See here, RxJS indeed. So that's good. I love to have observables a little bit closer. And yeah, so for me, it's always the trade-off. And I think a lot of people can resonate with this feeling. You got a deadline and you need to deliver something. And of course, there's like a ton of other blockers that are not related to fixing your code and making it clean. I had an issue with the Kin API on Sunday for like hours, and then I had a power outage on Monday for like hours. These are all things that make me more in the mood. Like, I'm super happy that I didn't try to figure this out before, and I didn't rewrite in my app. I half understand. But it's definitely a nice idea that I can at some point just make my mental wire and make sure that it all wires up, and that I understand, hey, if I change something there, I have a guarantee that this stuff re-renders, and I actually feel that I own this whole process, and it's not like it is right now.
So what we're going to do while this is finishing loading is we're going to create an injector system that knows about our various features. So where your database is, I have to go back to my screen to where you are. Bear with me. Okay. It's still installing. All right. So in there, let's just create a database or you actually core. You can do this with core.injector.ts.
Perfect. Yeah. I think everything will be hogging right now, but I'll make sure that I do this. It even looks like, it feels like it's doing the whole npm install. But we'll get there, we'll get there. Always good to have a little bit of patience. So we're gonna create the core injector.ts. Injector.ts.
And in fact, let's see, you have a core injector. So as you know, naming is hard, right?
Definitely.
Agreeing on names that you like and everything. Whatever name we choose for this file, later we may come back and tweak it. But we want it to be very clear that this is the injector. It's not, and it's going to be an injector for a whole bunch of services. So when we say injector to everyone listening in, what we really mean is this is a dependency injection system. And the injector is going to be available in the context. So you're going to say use context as the React hook. You're going to say use context, and the context I want to use is the core injector context. Okay. So obviously you can see here we're just working on the injector now. Then we're going to have to work on the context for it, but we can come back and do that. All right. Because first we configure the injector to know how to build our services and other things that we want. Then we have to make it available in the view hierarchy via the context. and then someone has to look it up and say, hey, Injector, give me some instance of, or give me an instance of this service. That's the 3-step process.
So this injector is going to be initially instantiating our database and making sure this can be accessed. I think at some point we will get the message from RxDB that says, hey, you're already instantiating a database with the same data set. It has some check that you explicitly need to allow multiple databases. So I guess that's a good objective. I'll be happy if I see that, because that means that we instantiate the database twice, once using the classical way and once using the other. It looks like this installation is mostly done. The editor is catching up with some more indexing, but I think we can safely go ahead and write some code. So,
okay, so first thing we want to do is we're going to create an injector. So we'll just export a const and injector, and its type is a dependency injector with a capital D and a capital I.
Injector, and this one should come from.
Does your editor allow you to just automatically import it?
It does, and it does a great job while it's not indexing. So
got it. Okay, so you can import the dependency injector, and that's from the mindspace-io/React.
Perfect.
Okay. Now this one is going to be, and this one we also are going to use a construction method, and we'll import this one. It's called make injector. So here we define the type of the injector, but now we want to make an instance of it. So this is just a factory function that hides the details, okay? So now what we want to pass in is an array. This gets
array.
An array. Mm-hmm.
Yeah.
So this gets, and then we're going to configure it. For those of us coming from Angular land, what you're going to see here is we're going to provide an array of providers. We're going to define some providers. For those of you who are not familiar with that, I have a blog article up on Medium that talks about universal dependency injection, and it has diagrams and it talks all about it and walks you through it. So I'm not going to go into that level of detail here. Okay.
I'll link it. I'll make sure it gets linked down below.
Awesome. All right. So what we want, the first provider is just an object. And you should notice, you should start feeling really comfortable with this approach. So, right, you can already see. So we want to provide. And what is it we want to provide? Now here's the trick, the challenge, okay? You did not create your database with a class. You created it with a function. So no one can ask for the database of some generic object, right? If it was a class, we could say, give me an instance of this class. That's right out of Angular. But since it's not a class, we actually need to define an injection token. Does that make sense?
But this one does, so that this factory function does return a database.
Oh, it returns a data. Okay, so let's do that. So then database, is that an interface though, or is it it is an interface? So you can't say, I want to provide a database that's an interface. It's classes, right? Because it has to be some tangible symbol, something that when it gets compiled to JavaScript code, to ES6 code or ES5, because remember for everyone here, when we compile our application, this interface goes away.
That's compiled away, yeah.
It's compiled away. So we need something that persists after compile time. And if it's not a class, because classes would persist, if it's not a class, then it has to be either a symbol or some other class. So what we're going to do is we're going to define an injection token. Let's go back to here, and now let's import an injection token right from the Mindspace one here.
Yeah, and this now it should be autocomplete injection token. There you go.
Okay, so we're going to say const, and this would be just token database _database is equal to a new injection token, and let's give it a string that describes it. This is your what? Your Rx database?
Yeah. Happy with that. Or maybe even.
Yeah, you don't have to worry about having it very short. You just want enough information in here that really makes it clear what this token is going to be used for.
Like core database, so we don't leak out that it's implemented with RxDB.
Okay. So then, now what we want to say is we want to provide this token database here. Okay. And we want to use a value. And the reason we want to use a value is, I think, is we want this thing, as soon as the injector gets called, we want it to start trying to load this value.
Yeah.
Right? So we'll just say colon, and then it's new. Let's go back to your create thing there, where you had that.
This one?
So for now, you can just import getDB. And then make a function call to that. So that's open and close. Yep. So now we have our token database. So if someone asks for the token database, we're going to use the value that comes out of getDB. Is that a promise, by the way?
It is.
That is a promise. So that creates a tiny bit of a set of challenges, right? Because we don't want the injector returning promises. We want them returning objects or data models.
The result of the promise, right?
Right. So probably what I'm having to think about this here. Can you go back to your getDB? So here you're calling create database. Let's drill into that. And what I want to do is I'm trying to figure out this process.
If you like, I walk you over it. I think it's fairly simple.
Okay.
Setup of the plugin, so the database knows what operations it's going to have. And then this and these, these ones, these operations are promises. So as you can see, doing a create DB, this is what RxDB dictates us. That this is a promise and that this is a promise as well. I think we could write this in one promise chain, but that wouldn't really make a difference. We need to await this promise, and if we have a result, we can figure it out and add the collections. And then what we do here is basically caching. I think with this in place, we're actually not going to see the, hey, I already got a database, because we will return the one that gets created already. So there's a little bit of caching that prevents this code from happening twice, and circumventing this idea. But yeah, this is a promise. So it's as I said, it's a challenge for me trying to figure out where I do this stuff, where I wait till the promise get resolved and set up the collection and do these things.
Right. So in terms of DI, this is sort of an inversion, right? I can't recall, this is why I'm hesitating. I can't remember if the DI will support a promise under the hood and then resolve with that, or if it really expects an object that comes back. Typically, it expects an object, right?
Yeah.
So in a way, this database is sort of an inversion of what we might normally do. We might say, we're going to create a database class, and the constructor would start this asynchronous process. And then that database class would have properties called settings and wallets that are default to empty, or to empty objects or whatever. And when the constructor of that async process finishes, then it would populate, and then you'd go from there.
I like the idea. And what we might do is add an additional implementation here, which is basically our core database class, whatever we're going to call it. Use that to wrap whatever, or to execute whatever this function does. I'm happy with reworking this. As said, this has been my go-to snippet because I know it works, and that's about it.
So let's do this. Let's export a new class called, and we'll call it core database. Core with a COR. And it implements the interface database.
Perfect.
All right. Now, your database has how many properties in it?
3. There's the RxDB, the wallets, and the settings. Let me actually put this as a comment here so we can take a look at the interface. So this is what the database is representing.
All right. So one of the things we can do here is right now, there's some tricks you can do with constructors, but I don't want to get too fancy just yet. Let's go ahead and create these 3 properties like that. Right. Now, these aren't optional. They are defined.
Yep. Let me make sure I'm importing the right ones. These will all be defined, you say, which to my knowledge means we need to do it all in the constructor.
That's right. So we can still use your getDB, right?
Awesome.
So we don't have to, we haven't lost that code. We'll just say getDB.
Or use the create database directly.
I would probably do it that way, actually. Create database. And then .then. And what comes back is that structure, right?
This is the DB. This is actually RxDB that comes back. Let me double check. Oh, it's this structure. You're right. It's the structure that it's an instance of this database.
Right.
Well,
so
not really, because that's an interface, but yeah.
Now we could even just do the following. If we know the fields are the same, we could just say object.assign, the target is this, and the source is that right there. And that would just copy them all over, right?
Is this something you'd consider? You're doing your own code?
Say that again.
Is this something you'd consider to do in your own code?
This would be I would do this initially, yes. And then until it proved that it wasn't working, right? Because if you don't do it this way, object.assign, then like the first thing I would try to do is make sure it compiles, and I'm not getting compile warnings, because sometimes I just let the compiler tell me if I'm doing something stupid. The other thing is, you'll notice I'm trying to minimize the amount of code I'm actually having to write.
Yeah.
So object.assign helps me minimize this.
Yeah.
Because the only other way to do this would be to destructure the DB argument into 3, right? And then you would have to say this.db is equal to db, this.wallets is equal to wallets, and that's a lot more code.
I like this approach that we end up with, that we're probably going to run with, because at some point I'm going to add a new collection here. Maybe networks will be dynamic at some point, and I'm most likely going to forget adding it here, adding this manual reference, because now I need to take into account that I added here and there another place. So, yep, I can see this works. Now, we now, in essence, have some sort of self-instantiating database class, right? We instantiated, we knew it up, and it will go ahead and create the database and wire it all up for us.
Well, you internally create database already caches it and only gives you returns 1.
Yeah.
So you will still only have 1 database. However, this class instance will have this data on lines 10 through 12. Now, the challenge here is the following. We may run into this, by the way, is if you have UI that is dependent upon these fields, it uses the injector, it looks up the core database instance, it's looking at these fields, but they're not initialized yet, right? They're not ready yet because create database hasn't come back yet. Then, and not only that, but once you write the DB and the wallets and the settings, how does the outside world know that these guys have changed?
Yeah.
Right? Other than explicitly saying, hey, give me the current value. But if you have a reference to the core database instance, how does the outside world know that these properties are changed? And right now they won't. So this is something that we'll have to plan for and we'll come back and address.
Okay, so in some sense, we can say this is right now core database, but it might as well have been your SDK that talks to your maybe your REST API, which is pull-based by default.
Right? This is exactly a classic case, right? So, but instead of with a REST API, what happens is we return a promise. and then someone else is saying, I know it's asynchronous, and when that asynchronous process finishes, then I'll do something with the data. Here, the outside world doesn't know that there's something asynchronous happening underneath the hood. So we'll have to plan for that later. And this is that whole issue of making things reactive. But once we get this ball going, things just magically will work. It's pretty amazing. All right.
Got it. Okay, cool. So one nice trick that RxDB has up its sleeve is you can actually watch collections and execute things. So at some point when this evolves, I might get a bit more fancier and then have my collections endpoint basically emit a stream of values, and which would bring it more to like maybe a Firebase SDK kind of thing, where you can look at value changes and just collect these. But for now, I think we have a nice representation of this pool-based approach. Basically no way around it. This is what we have to deal with, a pool-based world. And then how can we get this to observable ASAP?
That's exactly right, right? You hit it on the head. This is pull-based only for the short term, but we'll deal with it. Now, the hack around this is you could have at the startup a please wait in your app that actually looks to see if the core database service.db is not null.
Yeah.
You know what I mean? It sort of it either polls it, does an interval, a set timeout, or it waits for core DB to emit a notification.
Yeah.
And that's what I meant by being observable is if this database here was observable, it could emit a notification saying I've changed.
Yeah.
Again, we'll come back to that.
And then really quick, if I would have RxDB as a native operator here, I would say, hey, I can add maybe a subject here, behavior subject, whatever, initialize it with something. And then inside this line 15, where we do the object assign, I'm going to say .next true. Now I can subscribe to the change. And hey, if the loaded property is set to true, I know I'm loaded and I can move on with my life fetching data.
True. However, I am very hesitant to tell developers to start using subjects because they often get into really nasty trouble later on, right? They make everything a subject, and that's a real problem. Second, many React developers don't know RxJS.
Yeah.
So this pattern of using RxJS at a high level, they're not going to do it, right? So what we want is a solution that is very usable, not only for people from the Angular world, but also is intuitive and natural for the React developers.
Makes total sense. Okay, cool. So now we have our core database service, and this then can be used as an injection, as whatever we inject, right?
So this could be used then, right? So now let's go back to your injector. Now we don't need the token. So we'll just add that import. And now we can say use class, colon. You wouldn't say new. It's just the class itself. This is just right out of Angular, by the way. So we wouldn't say new code because we're saying we want to use the class, not use an instance. We want to let the injector handle creating it when it needs to, right? So the cool thing about the injector is it will only create this class when it's been requested.
Yeah.
And we'll see that in a few minutes. So
let me go here before I forget and say here, I like this kind of logging. So I'm going to say a log constructed. And here maybe loaded DB. And this way we have some nice visual representation. And at the moment we do initialize it, we at least should see two console logs that share this to us, right?
Mm-hmm.
That's a little A-side here.
What we're not doing yet is we don't have a property in core database that says is loading that's true or false that we could easily do, but we can come back and we can refine this later.
Totally.
Also, the core database doesn't have anything coming into it as arguments, right? We don't.
Correct.
We're not depending on anything external just yet.
And the reason is that we do this right here, and at some point, these parameters, the adapter and the adapter name, internal name, these might very well become parameters here where we can say, oh, you know what? Actually, in order to be React Native compatible, I want you to load this storage backend, and for web, I want you to store that. But at this moment, I'm happy to do it right like this. Just initiate this thing and move on with our lives.
Okay, so let's go back to your injector then. We can comment out the token. We'll leave that in because we may use it for other scenarios. Now, the goal here was to have just the core services we need. Were we going to do any other things? We were just doing the database first, right? The database provider.
Yeah, and then
let's go to your settings one for temporarily and take a look at that though.
Yeah, so what I was suggesting that we look here, so database is first, and then settings is the one that's going to be immediately available after the database provider. And these two are definitely core, I would say definitely core functionality. And then from here, network down below, here's where we get into the feature area where we have like actual features of the database. But if I would look at reusing this code, I would probably at least reuse this part. And this is for me like core functionality that I can save settings, have database access, etc. Whether I implement here a wallet or a to-do list.
Well, let's go into the settings provider and take a look at what you're using with that one.
So the settings provider right here, I'm going to comment out a few of these details. And so what I did with the settings at this moment is just a database. And I am using the key in the database, the ID field basically as the key, and the value is whatever the value is. And it only supports strings currently because that's what I need. And then we load in the database through its provider. Then when this thing changes, I'm running this load settings method, and this load settings method will safely try to access the database. It will most likely fail a few times here because database doesn't exist, blah, blah. Sometimes eventually it will find it. And then these ones will be set. So I'm just setting all the values. I'm going to plainly store them inside this use state here. So these are going to have all my database settings, which at this moment is only one record. And then I'm watching these, that if we have settings, I'm going to figure out if I can find the database value, and if so, I'm going to set it. So the end goal is to have this structure available. And this it's not the prettiest solution, but what is the prettiest from the outside, it's nice to use because I can just say, hey, give me settings.network. And I never have to figure out, settings is actually a property which has a property, an object which has a property value on it. That's all like leaking abstraction for me. So what I tried to achieve here was a data structure with the key, whatever I want to set it to, and then the settings, one of these. Not sure if it makes sense or if I had a real hairy description of what is going on here.
So let me see if I can paraphrase what you just said. This code here is using the database and getting a copy, essentially, of all the settings that have been loaded by the database class.
That's what's happening here.
And then you have essentially an accessor for network, which is looking through all the global settings to see if any of them have a network setting.
Yep, correct.
Right? So in a way, this feature here of the network is really part of the core database, isn't it? It's a property it's like a getter that's based on the current settings.
Yeah.
So you could copy line 34 and now go over to your core database. And you could have on line 13, let's add a getter function, just a getter. Get. And then this would be network. Yeah, and it's an open, and it's going to return a string. Or does it return a string or something else, or a setting?
Yeah, it returns
a setting.
It returns setting. You're correct. It returns a setting.
Okay, so that's going to return a setting. And now what we're going to say is, yep, this dot settings. And of course, we're probably going to want to initialize a line 11 and 12 to an empty collection.
So initialize these one by newing it up, new collection like this.
I think so. Yep. Yep.
Happy?
I'm not familiar with the collection class, so yeah, something like that. Does it take anything in it, or does it?
Maybe no. Works. I'm happy.
Okay.
This is my modus operandi. If it works, I'm happy. And then here is where we want to say, hey, give me of all the items, find the one where item.id equals to network. And this should be, I'm not sure. All right. Okay. So, and this is promise based because that's our database is promise based, right? So let me add a small comment here. So prettier.
No, we don't want it. We don't want this to be. This is just a getter. We're almost just basically saying if anyone tries to read network, if the settings have been loaded, we'll return to you a finding. If it's not, we're going to return to you a null or a default.
Right.
So line 14 is definitely not a promise, right?
Okay. Yeah, let's get rid of that one. But the API that we have here, the settings.findMany is a promise-based thing.
Right. So then that's where you have the then.
Yeah.
I follow what you're saying. The why is the find many promise based? Is it doing anything asynchronous under the hood?
Let's go quickly check what it does. I think that's what. Yeah, this is returning a promise. So this whole database is promise based. And to that extent, we should probably just see it as a third-party API. So it was as if we had an API that returns our settings, and we need to fetch this setting. I think I got one shortcut. If I just want to get the network one directly, I could also do the find ID, find one as a network here as a string, but it wouldn't get around of it being a promise.
Right. So one of the things we can do is we can move this code here. Instead of having a getter, it could just be a property. And then on line 20, after 23, we can do this dot settings dot find one network. And then dot then. And then this dot network blah blah is equal to the.
I like it. Is equal to res. Pick up res here and get rid of this one, and then let IntelliJ help me. There you go. Private network setting.
You probably call it not private, but public. Just call it read-only network.
I think read-only won't happen as it's a promise set inside a promise. So it will say, I can do this because I'm no longer into.
No, that's right. Because so just call it public. Yep.
Cool.
Now, the reason I'm hesitating about this, will the network ever change?
Network change constantly. If we do this, if we go here and we change it, it'll change. And I might be even get more fancy. I might add at some point a URL parameter that lands you on the correct network, because I want to send you a link that takes you to this wallet that it's on the right network, pre-populates my address, and you just have to say, I'm going to send this to bman on the testnet.
Mm-hmm.
So network is definitely
use param from a router hook to actually get the parameter for the network. And if it's been specified, then you could set it, right? So in a way, the database this service is really sort of dependent also upon some network settings.
Yeah.
Right? We haven't planned for that just yet, but it really is. And if those network settings ever change for any reason, then this database would want to reload or requery.
Yeah, and this is what I think I at least from a functional point of view, what I did achieve here is that if the database gets loaded, this gets considered. And if settings change, now I need to figure out. So yeah, update network here. So if I click this one and I pick the other one, eventually the update network method gets triggered. Again, pool-based because I just trigger it manually. After doing this, just go ahead and refetch this stuff. And then I do load settings, and then this stuff happens again, and then this stuff happens again. So in a way, I managed to trick it into working the way I expect it to behave. If I change something here, it gets persisted, and this persistence triggers, or this method triggers this one, which in turn triggers this one, and it works. But it's definitely hairy.
Let's go back to the core database. The reason I'm hesitating here is that this is still, if we look at this code, this is imperative code, right? Mm-hmm. Not only imperative, but it's pull based.
Yeah.
So in other words, if settings ever changed in this instance of core database, the outside world doesn't know about it unless they requery.
Correct.
And that is in a direct opposition to what we really wanted to do, which is we want to create reactive type of approaches, right? And so we are definitely on the right path, because I feel that the way you have it with providers and lots of custom hooks works, but it can be really fragile and it can be brittle. I mean, if you make one change, it can be really hard to figure out why the other ones aren't working. There could be some race conditions potential. It's just, it can be challenging.
I think it's definitely, I would call it brittle, and a few pointers that way is, I think, question marks all over the place, having if statements like, hey, if we don't have any data, just don't do anything. I hacked in setting a default value here. It works. I've seen worse. I've seen way worse. You've probably seen way worse, but it's not at all. I don't feel confident about this code. And if somebody says your settings don't work, I would start looking here and try to figure out, make sense with this. So,
right. So one of the things, I would be doing is let's go back to your core database again. So notice I'm always still coming back to this as being sort of that initial, and it's really not a database. It's almost like it's a core facade, right? It's a service that's loading a set of wallets and almost like settings and wallets is almost like, if we think about NGRX or Redux, it's almost like a store, isn't it?
Mm-hmm. Totally.
Right. So this is really sort of mixing a whole bunch of things. It's got at least two stores. It's got a database. It's got a network, which maybe is the current setting, right? So line 13 and line 11 almost belong together, right? Which is because that's the list of all the settings, and then the network is the current setting, right? Or is it? Yeah, it's the current setting based on the current network.
Totally, and we can have another obvious one that will be here at some point. Is this dark mode? Yes or no? It's going to be a system-wide setting stored in the same database. I want to react on it when it changes. I want to have it a proper default value, but if you overridden it, I want that one to be loaded. I don't want to have you flash your theme between dark and light just because I can get my timing right. So I think the app-wide setting system, there's a few things you can imagine being here. But I don't think, I never see it being like 100 settings, but there might be like 10, maybe.
Show me I never took a look at this, but show me what the setting interface is, or the setting object is. Let's drill into that. It's just it's a record.
Yep.
Okay.
It's key value store, and I called it ID because it's easier in my database abstraction that the primary key is called ID, but if that wasn't the case, I would definitely have called this one key and the other one value. to represent what it really is.
Okay. Yep. We can come back to that later, but you can also use I think it's the partial generic around your settings. So then you don't have to have the optional question mark option indicator for your all your properties. Because if you say, like on line 1, just type in partial in front of setting with a capital P. Angle bracket there, and then get rid of those optional ones there. We'd have to define. So we have to define setting as an interface, and then expose, like, you know what I mean?
Yeah.
I was getting fancy here. Let's go back to what we had. But you could. There's an example where partial and other things can be your friend. Okay, cool. So let's go back to here. Often what you're noticing is when I'm writing software, I'm thinking about all these things, and I want to deliberate to try to get the initial steps correct, because then everything else builds upon it. And I'm hesitant to just rush off into one direction and then try to iterate quickly, because I feel like this is foundation work, right? So that's why we're talking about it.
I totally agree. And I think it's definitely nice to get these right. My gut feeling says, let's, for now, leave how we load the settings as is, and let's try at least to use this instance of the database. And then later we can look at, hey, what would be a better place to actually look for this data and mix and match and figure out if we have your network property, etc.
Okay.
So basically, comment these one out, and I'm just going to leave this in for reference, because it's also nice to see the route we took to get to a certain point. And then as the goal of right now is figure out that at least we don't no longer use this one, but we're going to use Injector core database here, if that makes sense.
Right. So let's go back to your class. And this is in right. Okay, so now we have our settings, our database, our wallets. We've got our constructor function. You could still leave in, by the way, lines 19 through 21. You could still do that because it won't hurt it, right? Along with line 13. You can enable all that. It won't hurt. Now let's go back to where our injector is. So we've said if someone asks for the core database, then use this class. But we can also do the, there's a short, just like in Angular, there's a shortcut syntax. And we could have just said core database. But let's leave it like this now so we're more explicit in our intention. And now what we want to do is we want to create a provider.
And this is what Chow already suggested. Yes, Chow, it can be used as the same value.
Right. So if it's not an object, if it's just a class, then the assumption is it's not only the provider token, but it's also the class that we want. And so the make injector would actually just create a new instance of it on the fly.
Yeah. So it can just be written as this, which under the hood expands to do this provides and use this class.
Now, developers may be looking at this going, well, why am I going to this trouble? Like I'm using a dependency injector to make an injector, and this is more work than just saying new core database, right?
Yeah. Yeah.
And the answer is later, we're going to come back and we're going to want to inject a reference to the network service that gets injected into the core database. And then we'll define in our injector how the network service gets instantiated, because that's the one that will manage the networks, you know, the current selected network. And then we'll set up an observing mechanism. So basically saying, hey, network service, when your current active network changes, let me know, because I'm going to reload the database.
Yeah.
Right?
Yeah.
And what we want is all these things to be happening behind the scenes without any impact or without any dependencies upon UI. We want these things. If I took the UI away, I could still do all this. That's what we want. That would be ideal.
Yep. totally makes sense. Yeah, but I think for me the idea of having DI is so baked in my web development experience over the last few years that it's really hard to imagine why not.
Right. Okay, so now what we want to do is create a context, and we want to create a provider higher order function that will, so here we're going to say the context would be the injector context.
Written like this, right?
Yep.
Create context from React. I
Yep.
think this takes my injector context props, if I'm right.
I believe it's, what's the argument for create context? It's just a string, right? Some value T. So it could be whatever you want. Oh, it would be the instance of the injector. So it would be a dependency injector. So that's the type. And right now it's just null. Actually, you could, yeah, we'll just call it null. Okay, so that's the context. Now we want to create a higher order function, which is the injector provider.
If I'm right, this should. I'm always now. I'm gonna leave you guide because I'm always not sure how to do this. Well, I do have references here because the settings provider is doing exactly the same thing. We create a context, and we have a provider function, and we eventually do the context.provider. That's what we return.
That's right. So let's go back to, and there's probably some shortcut ways, but first let's make this a functional component.
Yeah.
Okay.
Like I think like this.
So if you would you mind if I show you another way to create it? So
No.
I always creating it as well, since this is a provider that almost looks like a tag, but no, I'll do it this way. Do it export const injector provider colon react.fc functional component. And this is a type of dependency injector. So angle brackets after FC. Actually, this would define the props. So just say react.fc. Okay, you could do it that way. And now this is going to, there are no props. So we're not worried about props coming in here. And this is going to return yep. So here it's the injector context dot provider.
You know why it's not? You know why it's not highlighting? Look at the file extension.
Right. You have to say TSX.
This is
so this
something
one makes everyone like it made me crazy until I happened to stumble on this one.
Same here. And last time I figured out, it was like, oh, this is going to happen in the next live session. It does. And now we get nice cute auto completion. Okay, so injector token dot provider. And then what I think it's always going to be at least children as the thing because we want to use this as a higher order component, right?
Right. And now we need to set the value. Now I like doing it this way because then it's explicit on line 16 what the value is. And that value is just injector.
Yeah.
Now, people looking at this code may go, this is really weird. You're creating an injector, and then you're creating a provider that allows someone else to look up the injector. But, what's it complaining about?
It wants to have React like this. There you go. Yeah. But I think a lot of people will initially think, why all this? What is your gain with doing it this way, right?
So the gain will be later that we would probably separate these out, right? The context and the provider would be in a separate class, and the injector would be a standalone class that we could then add essentially all of our application global dependency services.
Right. Yeah.
And the thing to remember about the dependency injector is it does not create these services until someone asks for an instance of them.
Yeah.
And it caches them internally as singletons. So unless you explicitly say, give me a new instance, right? Give me a new copy, a separate copy. And that makes it really powerful because with the context, we can look up the injector. With the injector, we can say, regardless of where it came from, we can say, give me an instance, and the injector constructs it for us.
Makes total sense. Yeah.
What we've done is we've separated out the lookup from the construction.
Yeah. Very cool. And then another thing, I'm not sure if you have any follow-up comments on that. What I tend to do next always, and this is where I really started to like hooks, was like, oh, I can do this use context, because before I was doing it this way, use context straight away, but now you have settings context all over your app, which is also not ideal. It's for me, that's an implementation detail. I don't care which class implements context. I just want to use settings.
Okay. So you're basically saying maybe we should create a use injector.
Yeah, definitely. That would definitely be my my next step here. Unless you have other ideas.
No, I would suggest that we call it the hook. Call it use dependency injector.
Love it. If I can write. There you go. And another thing I often see is that these two are actually private, and then there's an explicit where we say, oh, you know what? I want to get this one out here and the injector provider, because that's what we need in the UI. And this is basically what I've modeled my things towards.
Exactly
and
right.
In some projects that I do this often, I actually have an NX workspace schematic that just creates this based on a name, because I see myself doing this all the time. And this is an approach I can definitely appreciate and understand. It's easy to wrap my head around, because for me, when I'm inside here, I'm actually sneakily inside a React component, although it's not a component that renders, but it feels that I'm still inside a React component. For better or worse, it's all a component. I like this one better because it doesn't render out. It just stays under the hood.
Well, what you've done with line 22 and the rest of the code is you have essentially, and by the way, you won't even need to export line 7.
Yeah, that one as well.
Once you start breaking these into separate modules, though, you may want to go back, right? But what you've essentially done is you've created a public API, which is use dependency injector and injector provider. Everything else is private. How it's done under the hood is all hidden. You can change it however you want, as long as what you've exported is the same.
Awesome. Yeah, perfect. And then with this name, injector provider, we also come back to the tweet you sent me, your reply yesterday. I can replace all of this with one injector provider. So,
right. So the astute observer would watch you and I and say, Thomas, your sleight of hand isn't working. You're only replacing the database provider with an injector provider. It's the same thing. It's one for one, but we're building up to it.
Perfect. Yeah, I love the suspense. At some point, we'll get to Akita. I'm confident. Cool.
Right. Watching, I had asked B should we do the dependency injection first, or should we do React Akita? And sometimes it's the chicken before the egg. Which one do you talk about first? And based on the provider tree that you had, that B had, we said, let's start talking about dependency injection first.
Awesome. And I think that's going to be a nice bridge, because once we have the provider, we can add another one to the tree, right? And I think this is going to be the top level one. It's not UI based. At least that's how I like.
Correct. So who uses the database provider? Is it only settings, or does network also use it?
It's settings. Network doesn't directly use it. Network just checks, hey, settings, what's my network? But wallets asks it right away, because wallets asks, hey, I want to know which wallets are there. Create a wallet, delete this wallet. So wallet provider will use DB and loading DB, and here we will see various DB ? Where it basically does stuff. So this is where your CRUD lives. List one, delete one, create one. Okay. I didn't bother implementing update yet, but it's going to be the same. So this wallet providers is the biggie. This is our CRUD.
Right. So what you'll notice here is you've done with your wallet provider and this hook is there's tons of business logic in here.
Yeah.
Right.
Yeah.
And it makes it really hard to test your business logic when it's wrapped in a hook. And so this is a great example of an approach that's reasonable for a first pass. But what we want to do is separate these into separate layers later.
Yep.
Okay, so we'll go back to the app tree. Let's wrap the injector. There you go, exactly. Now let's get rid of the database provider. We'll comment it out.
I'll do that here and here.
Yep.
And then when I do save after this, so let's render it first. Last time we're going to see it in a few seconds, in a few minutes. Now save this, and this will hopefully fail. Otherwise, it's going to be super weird. But this will most likely do an empty UI or even a failure. Yes, and the reason why it fails is that at some point I inject my database server and this no longer exists up the tree. So I do use database at some place, and this now fails.
Right. So let's go back to, by the way, our database injector.
Injector provider, and then to this core database here.
So when we say use injector, what we're going to be doing is we're going to be looking up the database. Okay, that's cool. So now let's go into your settings, provider. And where you said use database, we're just going to say use injector.
Dependency injector.
Yep. And that's going to give back, not an array, it's just going to give back the injector, okay? Now, what we can say is so we have a couple options. We want to say, hey, injector, give me the core database.
Yes. My naive approach would be const db database equals injector.get, and then core
database, right?
This would be my naive approach, and then I should be able to say db.wallets, there you go, db.settings in this case. And the nice thing is, for me at least, and this is if this holds true, I'm gonna hug you virtually, but still. Because if this holds true, that means that I can go into my wallet provider, basically change one line with these two, and it should still work. And if you let me, I'm gonna get.
Except the only thing here is, let's go back to. So what happens is on line 22, this is where I was talking about the sleight of hand, right? Because remember, line 22 is going to create a new instance of core database. Core database in the constructor is starting an asynchronous request. But on line 23, we're synchronously trying to use it, or later on, we're trying to use it immediately. And that's going to be problematic because we haven't guarded against this route, and we're just trying to create it for the first time. So things aren't quite ready. Does that make sense?
Totally. And actually, when I peeked into wallet provider, when I want to copy it, it also, here I do take this into account. I do this loading DB kind of thing. So I can at least check, as long as this one is not true, you don't even have to try reaching out because it will fail. Which kind of brings me to the point of maybe we should add this loading property here, initialize it with yes, I'm loading, and right here say we're done.
You certainly could for now, right? The challenge though, remember, is if you say is loading here, this is a pull-based API. So even if we set it to is loading is to false because we're done loading, doesn't mean the outside world is going to know about it.
We have to pull again to figure this out.
We have to. So we're going to have to come back and try to address that issue. Because right now, we haven't created any reactive stores. We've just created a facade that isn't even stream-based, right? It's just a facade that's doing some things. And it actually, because it has an asynchronous nature, it's not going to work the way we want if it's still in the loading process.
Yeah.
Right? And the only way around that is to either block access to the requests who would use this information until the database is idle, or make this database be reactive.
what would be your if you'd, let's potentially say we have 30 minutes left. I'm having all day, by the way, but if let's say we have 30 minutes left, what would be the quickest way to mark it for now?
The quickest way would be to block it, right?
Perfect.
Really, just not even show any of the nested UI components until the database is done.
Perfect. And then,
so here you would probably, we're going to create a UI component that's essentially a guard, right? Like a higher order component that would then use this.
if you let me, I'm going to call it AppGuard.
Go for it.
Then at some point, what I want this thing to return probably is going to be all this. Then here have some condition. And the beauty of React, this is one of the things I love. If condition, just return whatever, nothing. This will not render.
Or just return null. If you return null.
Oh wow. You know why I stopped returning null? Because React Native pukes if it sees null.
Okay.
I think it's either null or undefined, but this is one of these tiny little nuances. Now and then here we're going to say this is my app guard. This is all good, and now we basically inside this fella we have to figure out only display this whole tree of components when this condition is met.
Right. So here in the app guard, we're going to inject the dependency injector just like you did in the
use dependency injector. There you go. And then we can say injector.get, I presume, and we're getting our core database again. We can even say that this is my Const DB. Please stop me if I'm doing things very differently.
No, this seems.
Now here, I think I could get away, and I'm definitely not sure if this is the right approach, but I think this already might give me at least direction of where I want it to be.
So this won't work just as it is because this is a functional component, and the only way to get it to re-render is by changing use state, right?
Right.
So that's the first thing we need to do is after the, I'd probably do const above 27. So yep, const, you could say is ready, right?
Just a normal const, not a use state. Yeah, it's use state, right? Yeah, set is ready. And we're going to start this off with false, if I understand the intent correctly.
Correct. Okay. So now we've got our injector. That's cool. Now we want to use a correct. Now, one of the things I do here on line 31 is just copy out the not is ready. Cut that out. Okay. So we're going to use a ternary operator on line 35.
If is ready, do this, and otherwise null. Null it up, null it out, however you want to call it.
Correct. Now we're going to need to use effect, right? Because we only want this to happen the first time the app runs up.
Okay, that makes sense.
And we're depending upon the injector.
We're depending upon the injector to being here.
Mm-hmm. Now, and that's all we're dependent upon. Now, what we can do is we want to get an instance of the, we want to get an instance of our database. Mm-hmm. So bring line 29 in, there we go. And now we have our database. However, we don't have access to that process, right? Because it's in the constructor. However, we could have access if we go back to our core database and take all the constructor code, and instead of calling a constructor, just call load.
Sure. I would call it init if you let me.
And it's going to return a promise.
And I assume it's going to be return the promise of database. At least if this is
Well, so that's the thing you don't want it to do, right? Because if you return a promise here of the database, then people have now access to a reference from a init, but they all also have access to it from line 10. Because we also have this RX database, which can be confusing. So what I would do is you could return a promise of is loading, true or is ready, true or false. You know what I mean?
Mm-hmm.
You have to decide what you want to return. So
okay, let me go back. I'm going to call it load, and I'm going to do just as you suggest, a promise, and the promise we're going to return is then a Boolean.
A Boolean for now. Okay. Now we're going to call create database with all this other stuff.
Mm-hmm.
So let's copy 17 on down. And so here we're going to say on line 27, return. And then on line 33, we're going to say .then. And just return true instead of an object. You don't even have to do that. Just return that arrow, open and close parentheses. There you go.
Right.
And so now, of course, this doesn't handle the issue of returning, or reporting an error and all that, but we can come back to that later, right?
I like this.
So this is good. So now now in your constructor, you could also call load. But if you do that, then you could have two load processes, right? So
I'm fine with my app.tsx with my guard loading this personally. I'd be happy. This
is the short-term solution until we get the core database being truly reactive, right? This is a workaround that, right? So this is not what I would want at the end goal. Like this is not what I would want someone to submit a PR for, but it's certainly reasonable while we're refactoring.
This is going to be core database loading, core database loaded DB, and we're commenting out anything that's in the constructor. And,
that's right.
As we can see, I don't think you all can see it very well, but here we already had these one core database constructed and loaded. So if I hit save right now and everything compiles, we should see core database loading and core database loaded.
Now let's do a couple things to make this our code more declarative. Go back to your core database.
Mm-hmm.
So what we're going to do is we're going to create database with the adapter and the adapter name, and we're going to assign it to a const called request $.
Where are we going to set this const?
Right after console.log.
Request $= equals this?
Yep. So request $, usually we use $1 when we're talking about streams, but I also tend to use it for asynchronous stuff, right? Because it is like a pending stream that will return later.
Yep.
Now, the other thing I would do is, because what we want to do is try to make this as declarative as possible, which means that if someone looks at this code, they can see immediately what's going on. So the other thing I would do is the find one.
This one.
And then, so where you have the .then, maybe I'd take that closure and assign it to a const, which is, update network. And I'd put that const on line 29. Nope. You could just call it const, right? Because then it's just consistent, like a top-down read.
Yeah, I was about to ask you if you have guides when use function and when use const. I think const is often used. I think most React apps use mostly const, but I see things that I don't really see the benefit. Function is shorter, even though const somehow people think it's shorter. It's not. It's more characters. It's longer line by a few. What's your take on that?
So const also has the issue that it's a fat arrow, right? So there's there's an implied closure access, but the same with the function, right? They're almost synonymous. I have found that it's just harder for me to visually, cognitively see a nested function if it's defined as a function. If it's const, I'm looking at the top of the stack of this block. I'm looking at the top for all the constants, right? Yeah. Because they're not hoisted. So I'm looking for the constants. And even if it's this update network is a closure function, it's still something that I know is used only in here. So it's probably a matter of style, but I found that it was helpful for me.
Yeah, I think the biggest downside I had is with debugging, it's an anonymous function. It will not represent with name, so it can be harder to figure out exactly where did it go wrong. I don't think React with TypeScript specifically has the issue. It seems to pinpoint pretty well where things go wrong. But this is basically the classic con for doing fat arrow functions in a constant. Cool. Okay, so we cleaned this up.
Right, we cleaned it up. It's more declarative, right? I don't know if I would do any more than this just yet, because the settings and the find one is the network, and then we update. Right, you could change that name if you want to, but this seems reasonable. Right, now later we could also we could move the console log into a separate then.
Yeah.
Right, if we really want to be clear. So above we do it right there. We go, and now all of a sudden it starts looking pretty reasonable, right?
And actually, as long as we're on it, let's then go ahead and up it one notch, and maybe even like this. This should actually, for me, this would be load network, by the way. I think I would do load network.
There you go.
Which has a method, and I would create this method here and return whatever it does. And there is the update network. And now you can see, you know what, this update network, we might as well toss it in here because it looks more like the rest this way.
That's right.
But yeah, there's probably also here a lot of taste and a lot of style involved.
The only problem with that is if you did that as a private, you're going to definitely have to specify that it returns a promise. And you probably want to make it private because we don't want anyone else messing with this, like watching it. Right? And so that's
going to live above my constructor. That's some other thing.
Mm-hmm. And then I would just get rid of all your comments in your constructor. In fact, I don't even think you need your constructor just yet, right? You could get rid of the whole thing. Now your code's looking pretty clean. And beautiful. Now if we go back to your wrapper function.
One small short comment. The one thing that I already like about this benefit, this allows me to pass in the adapter and the adapter name, which will then bring it to the app, which by default will make it React Native compatible, because now I can just load it in with whatever thing I happen to use when I initialize my app, which makes a lot of sense. Makes way more sense to have this in app instead of having it inside some provider somewhere in core. I'm not going to do it right now, but this is definitely something I see as a huge advantage.
Now, what people may be wondering is, well, wait a minute, why are you doing the injector here if you're having to call load on the data, the db.load, which is what you're going to put in here. So go ahead and do that. And then once we hit load, then we want to say .then.
So here's the thing. This is not a database. It's core database. So
correct.
But then where we get.
Yep. And then we would say set is ready.
So here's the thing. Set is ready. Let me first do it.
That won't work, right?
That will work.
Actually, it should work, yeah.
So here's the thing. If it breaks on wallet provider, I'm glad. And let's quickly see. That's the easiest way to get an answer. Wallet provider, there you go. Like for a second here, let's do this for a quick second. Add back this old database provider because it's kind of dependent on. I think the app right now should render out just as it would normally. And we did get a nice handle. Okay, it almost renders out. But we did get a nice handle on. Well, here's my thing. Yay! I said this before. An RX database with the same name and adapter already exists. I said it would be a mission accomplished for me if we get to this point, because this means we're loading in the same database on two different ways, two separate channels, two different instances, two different objects, two different DB promises. So we're getting here, and perfect. I'm happy so far. And this, having a guard like this, I never really considered it, but I like this. I can definitely see this replacing, let's say, an app initializer, if I'm going to put it that way.
Right. So the good thing about this is the other thing you could do is inside this guard, app guard, make it a functional component that accepts children.
So const, this one is a FC that gets from React equals this children fat arrow. Bam, there we go.
Now, instead of app layout, just render children, and we're going to put the app layout outside.
Love it. Yeah, so this is going to be a whole chain, and then here we're going to go back, make this one there, and there we go. Oh, this is beautiful.
Right. So now what you've done is you've essentially separated, you've partitioned better some of this complexity, right? Yeah. So from the app level, okay, you have an app guard, and maybe maybe later you change it to database guard, right?
Yeah.
Which is really what it's doing. It's guarding against any nested UI until the database is ready.
In fact, I think it's a better name. So let's go ahead. And this is my friends, one of the great things of React. Just search and replace thing, re-renders. No need to register inside a module or any other references. So. Okay, now, I got a database guard. What I really like about this, I think this one should not live inside app.tsx. There's no valid reason why it should. So that's nice. It also really hides anything we're going to do at some point here.
That's right. So if you broke out database guard into a totally separate module, which I would do, it's going to clean up your app.tsx quite a lot. And it insulates you from making further changes to sort of a reactive approach.
Yeah. So this is basically your database guard.tsx right here. Let's stick it. I'm gonna do reorganizing at some point. But we did manage to get a nice handle on loading the database, not loading anything else. So we're getting to the place where settings provider and essentially wallet provider can now easily be changed to using this. And
now this still seems clumsy, right? If anyone was looking at this fresh, they might say, well, it looks to me like Thomas just added more complexity because we were having to use an injector to look it up, and then we're telling it to load and all. But remember, later when we use the dependency injector hook again down in the views, we're no longer telling the DB to load. The DB will be ready, and now the injector just gives us an instance of the database service that's ready.
I really like it, yeah. So this means in my settings provider now, and I think I already changed it here, and this works, and I really think the thing that's complaining here is now my wallet provider because it cannot load its dependency it has. And then right here now, I should go be able to change this. Now this loading DB, I'm using it at some place, but I think I'm using it once. Twice, but I should be able to get rid of this one because it's always loading in this one and make sure that I syntactically correct my stuff. And then I could see this one from being working again. There you go. It seems like it's working, and we finally, okay. Big one. This one for me is a big one, and it might seem a small step for developers, but it's a huge step for me. Let's put it this way. I'm definitely happy when I see this because for the first time in my React app, and I think that's not a hyperbole, I feel in control of having a life cycle again, which is something we lost when we moved to functional components. At least that's how I felt. I liked component did not mount. Didn't like a ton of other things then, but I can really see the usefulness of being here. And yeah, so this is definitely a worthy refactor. And actually, I think, let me use a different branch, BLS031. I think this is going to be one commit where I say basically implement my dependency injector. And I will probably need to clean it up, but this by itself, I think, is a pretty clean refactor, what we do. And what I'm curious about, if I can get rid of this one, okay, so I have core database provider, but this database provider is no longer being used. So we should be able to get rid of this one, that database provider. It's referenced here in index, so I can get rid of this one. And then I should be able to get rid of this one and still compile. This might have gone fast for people that are following along, but if this renders into a compilation, we just got rid of a bunch of, what do you say, brittle code is the best way to provide it, which was how I loaded my database. And we've merged this into a nice, consistent, and reliable way. Don't do anything before this event, this asynchronous event happens. And,
right, so now what we have is, we have a couple of things that are going on here. This core database, so the name, it really isn't a core database, right? And we have the RX database, which is cool. And then we have these services, well, these stores, settings and wallets, and the network. The settings and wallets are really stores that those are, where are those populated? Those are down in create database.
So, I mean, their database, I would love it to, if I'm going to build a reactive data store on top of it, I would love it if this could be just its promise-based API. Give me one, give me many, just as if it would be like Axios on a remote API. So if we're going to think about having a store that, for instance, loads the settings and allows for updating settings and eventually persist them back to the actual backend, I would love this to be basically intact, as I like the API, and add some, I don't know where, but maybe here add some more intelligent layer that can actually do stuff like watching them and anything we'd like from a store, making computed properties or making some calculations. I got a really nice use case for a computed property in my wallets, where the URL to your wallet explorer, here this URL where you get, depends on which network you're connected, because it depends on which network you're connected to which link I'm going to send you, which I think is a beautiful reactive or computed property.
So the interesting thing about the so the reactive store has a primary method called create store. Mm-hmm. When you call that, you specify the state you're managing and any APIs, and it's pretty simple to do. And what you get back is you get a hook that is implicitly tied to the store you just created. And you can use that hook in any views you want to get access to the state and the API for the store you just created. And that store is reactive.
Right.
What the store doesn't have is it doesn't have, because you have a hook, it's harder than to say, well, what if your store actually wants to use a service, right? And now you know where I'm going with this, but you want to use maybe the database service, the RX database service, but it's managed by the injector. And so that's the next thing we're going to be thinking about is how do we start using create store and reactive stores, but that we can inject in services that are needed by that store.
Correct.
Right?
Yeah.
And if we solve that problem, then we can start creating stores at whatever level we need, and then they're just available to anyone who imports that hook.
So in essence, what we want to do is we want to have some data structure that allows us to pass in maybe either core database, or maybe say, hey, you're gonna get a collection of something. And now you know that this collection is going to have find many, find one, create, update, delete, however you do it. So that the store is not married to our RxDB implementation. It just accepts some contract of some service it can use to actually store the data. And it can do all the operations it needs to.
Right, because the store can work asynchronously, right? As long as it has a service that gives it a promise or a stream, the store can do whatever it wants to do, that it needs to do. And then when that process finishes, the store can update its internal state.
Yeah.
And then that triggers all external observers through the hook to re-render. Like it's really super clean and beautiful, right? And that's what I meant by us first working on dependency injection, and then later we'd come back and start looking at the create stores.
Yeah, I think we should definitely do a separate session for picking up the stores. I think what we did today was definitely a super valuable way to do this. In fact, I think I can more or less, without looking up any reference to this, I can implement my price service, which is kind of a one-off database or one-off API call where I just do fetch prices of whatever the currency is worth right now. This also needs to bubble down. And then next time, try to focus on how to actually store these wallets in a data store, because right now, as we already mentioned a few times, it's super imperative. If I do the load wallet stuff, we can take a quick look here. I need to have this DB, which I now loaded. And then at some point, I do so many things here. It's not even funny. But at some point here, I have a reload method, which says this DB wallets find many. I even do sorting. Well, my database just supports sorting. I just didn't figure out how to make this a clean parameter. And here I do a mapping over all of these, and I say, hey, give me the Explorer URL, which is this little URL here, and call into my service and figure out what is the Explorer URL for this public key. And the reason this service can tell me this is that this service gets initialized with my network. So my service needs to know I'm on this network. This instance of the service connected to this network. Now, I've built various crypto apps, and I generally end up with something like this. In some apps, it makes sense to connect to 5 networks at once, and you want to all service them. So then you basically set me up any networks that's in the database. The use case here is we want to have the opposite. We're only going to be connected to one network at once. It's going to be super hard from a UI. Makes sense if you could say, this wallet lives on the testnet and this wallet lives on mainnet. It's just not a valid representation. So, and then this has it's basically dependency injection, right? Even if I do it manually when I new it up, this kin wallet service lives in my network provider, and each time I change a network here, I set a new service here using this thing. So I think there's a few more iterations we can go over with DI and doing this, but I think you gave me the building blocks, so I'm super happy and excited about that one.
Let's go back to the use settings hook. Let's take a look at that one. That was the next level down, and I just want to make sure. Yeah. So one of the things that we have to be careful of is that before we start doing this, let's go back to the core database.
Yeah, and let me call this thing actually now. We can just give them a proper name. Whatever, I wanted to rename, but it doesn't let me currently. Get back to the core database. Here we are.
All right, so this core database is right now it doesn't trigger any reloading if the network changes, right?
Correct.
And do you want it to ever do that?
Ideally, ideally it goes automatically if it changes somewhere.
Right, but when you change that setting right there, if I look at the code on the left, what's being affected? Is it the DB, the RX database that needs to reload?
No. Let's quickly go back. app.tsx inside here, we can see that, if the setting changes, network goes. Prices, I think prices can live up. Prices, I don't think, oh, look at this. Prices do need network. Yeah, okay, so I kind of took a stab at some point, I want prices to be relevant for network. So let's consider I got my own local testnet, kin test network. I got my own test network, and I want to be faking the prices because I want to make sure that my UI still works if one kin is worth $1, right? So prices are dependent on the network. So if that changes, if the network changes, I want my prices to be reconsidered, and I want my wallets to be at least re-rendered. They should reconsider like, hey, do I have actually account on this network? Do I have an account on this network? I think you can see it pretty well if I switch to network. These two ones, account 1 and 3, say, hey, I don't know, I don't exist on testnet. I asked on testnet, what's my balance? I get back, account doesn't exist. So this is kind of the idea. Price might be another one. So on test network, we might fake a higher price for reasons.
Okay. So going back into the core database, for some reason, I just fundamentally feel that the name of this class is misleading, right? Maybe it's because of the nature that right now it also has stores in it.
Yeah.
Right. So maybe this is in a way, this is it's nice to be able to separate out services from stores in a clean, layered fashion. That's probably the first thing you need to be thinking about is which sets of my code is really related to a service and what set of code is really related to state that I want to trigger UI re-renders.
So with that being said, I would definitely feel better if this one was called core service.
Yes.
That's more generic. That also happens to have database access. That's totally fine with a core service for me. I'm going to call it like core.service.ts, and I'm going to hope it will say, I'm going to rename it for you. There we go. Did not rename this one. Let's do it manually, core service. That's cool. And then I can probably do a good old classic search and replace. Let's go ahead and do all this. And there we have it. And then this file is empty, which is great. Delete it here. And now, okay, this one adapter doesn't get imported. And I know that is a lack of typing. But
well, you could quite easily pass it in as a constructor via the injector.
Yeah, or do this loading here, as we suggested. And then now another thing. This is probably not a common. This might not have a common answer. Would you gut feeling here? Would you say load takes 2 parameters? It's adapter, and the second one the adapter name, or it takes an object, which is core service loader that has a.
Well, I'd even ask a different question, which is if you pass it in as load, that implies that load could be called multiple times with the different adapter and a different name.
Correct. Once on React, once on React Native, for instance.
Right, but it's only called one time for the whole app.
Correct.
So then I would never pass it in as arguments to the load function. I'd pass them in as constructors, constructor arguments. Because this service is going to be created once for the whole app and it's never going to be reinstantiated.
But I love that idea. But the what I like about it as well is here we have momentum where I can stuff it in, and I kind of lost having the new core service. I'm not newing it up manually. This is what the injector does for me.
Okay.
So where would I?
If it's 2 arguments, I just pass in 2 arguments.
Yeah. Okay. Yeah. I think, I mean,
It's when you get, for me, the rule of thumb is 4 or more.
I like that. I like these kind of
4 arguments, then I do it as I start thinking about consolidating either into a second argument of options or as a single argument of everything.
I guess I don't have it for. I do have some mostly gut feeling that's like, no, this is no longer clean, and then I look at like whatever can be optional is going to go in its options object, and only ask for the real required stuff.
Right. So here, by the way, do this. Unload the function call, the second argument. Don't just declare it and initialize it as the string IDB.
Love it.
Since you've done that, you don't have to type it. Now you can just get rid of that.
Get over here. Yep, I like it. I like it. Awesome. This is coming together pretty nice. It already addressed quite a few issues I had. Mainly, now if I'm doing a React Native app, which I'm doing, what do I need to abstract out and what can I reuse? And it looks like at this moment, at least, that my whole core stuff can be reused and can live in a nice separate library, and I don't have to worry about it.
Now, one of the things you're going to be doing, ideally between now and when we next meet, is you should take a look at your other parts of your code, especially the ones that are in your other providers, and see which parts are actually making service calls and doing business logic, and move that code into a service class.
Yeah.
And then find out which parts are really just sort of holding on to data state and are reacting to changes in that state. And that's the part that we need to start thinking about how we're going to make that reactive. When we come back next week, we can look at two things. We can look at using create store to easily create reactive stores that have a hook automatically tied to it, or we can create facades that under the hood are using Akita manually, and actually, and then we use observable to actually watch the streams coming from our facade and extract the data out. So that use observable is also from the Mindspace.io library.
Yeah. So what I'm thinking about doing is first go over this and make sure that I get exactly what we've done. I think the injection part is fairly easy to follow. What I think my next candidate should be this fella. 200 lines of code. I don't like it at all. And here is the result of me struggling against a few external factors. Like I said, API blocking and my power outage. And I just got like, I need to get this thing done. It works. But I pretty much hate whatever I came up with. And it does so many things in a hacky fashion. And I think one of the results of that you can see is whatever my provider here exposes. These are like 5 concerns. We can go over them in detail, but this is just way too much. This is like on a blink of an eye, you will not understand what this thing does and why this thing does certain things. And it was worse actually, because first make it work. So I had like, for instance, it did price check in here because it was just like quick and dirty, got momentum here, do the price check. Should get out of there. The price check should be somewhere else, not here. So what I think I'm going to do is add a wallet service and try to do any of the hard work inside that wallet service and just make it a convenience API that's going to provide a service to this provider.
That's right.
If that makes sense, yeah.
The goal is that if I said take away all your providers and all your UI, and you want to run this through a script or even as part of a test, that you should be able to, with the injector, to inject in mock REST services, and your own services that would use the mock REST services should then still have all the logic to loading the data, to manipulating, to building your stores. If you can do that, then you then come back and then you can add providers or custom hooks to use that at the UI level.
Yeah, makes total sense. And I think that's a really clean consideration. And at some point, not this month because there's just too much happening, but at some point, I'd love to go back and look at testing with this again. But I'm gonna have some more testing live streams in the future anyway. But this would definitely be a nice target. Also because like it's handling financial things at the end. I would love this thing to be super solid and well built and well tested. It's going to be open source. It's going to be one of my projects that I attach my name to. So I'm definitely hoping to do just that. Yeah.
Okay, so we've gone over a little bit. I have another meeting. You're going to laugh in 12 minutes.
Yeah.
So let's meet again next week. And next week, definitely let's work on reactive state.
Ciao, you will get Akita. You really will. You just need to be patient.
He doesn't believe it now.
Yeah, I don't know. I'll hopefully convince him. Ciao and I did like three sessions on component store and one on component store testing. So if like what is it? 150 files library can have like 6 hours of content, we can definitely do some content on React and getting these things right. Thomas, again, I really, really appreciate your time spending with me here looking at my app. It's been an awesome session. Really appreciate you being here and sharing your knowledge. Thank you so much.
Thanks, Pete. See you next week. Bye.
Awesome. Everybody, thanks. Bye-bye.